if I'm making my implementation of a stack, okay, this would be a good place to start. Okay, I have a stack, and that's the name of it. Okay, but I want to say something. I want to say this will implement the behavior of a general stack. Okay, so we say it implements the interface. We can already, if I try to compile this, okay, it's going to give me complaints. It's going to say ArrayStack is not abstract and does not override abstract method pop in stack. Okay, so this shows you this is like a rule. Okay, if I want this to be a stack, it has to implement those behaviors. Okay, one thing I shouldn't forget is my type parameters, which is always going to be a thing. But again, I'm just saying I'm going to hold some unknown type. Okay, whoever uses my implementation is going to provide us with this knowledge sometime, hopefully in the future. Okay, now to actually model my stack, I'm going to just, object. I'm going to have internally an array of objects. Okay, so they're basically the most general type you can imagine in Java. Now, the reason I'm doing this is primitive arrays and generic types don't often play well together. So we're going to start getting warnings in the compiler about some of the things we're doing. But all we need to think about this is the stack we're going to put things into. This is the array. Okay. Then the other thing I need is some type of pointer. Okay. So this is going to be my pointer to where the top currently is. Okay. So let's have a constructor. Okay. And this is where we make the decision. Okay. We need to decide, okay, how big is this going to be? So stack is a new object array of, let's say, size 10. Let's copy Java. Let's copy the developers there. 10 is a good place to start. Okay. Also, we need to initialize top to a sensible value. And we already, if we go back to our kind of theory on this, we know that to make our life easy and to give a good signal, if top is less than 0, then we know it's empty. Okay. So let's say that's -1. Okay. So far, so good. The E inside the angle brackets could be replaced by T. Yeah, this is pure convention. Okay, I could, if I wanted, just say X as my type parameter instead. Okay, Java will not care. The reason I chose E is that I'm working with a collection type thing, a data structure, and element makes a lot of sense in this context. Okay, so yeah. Could be anything, but it's sort of, you'll notice in the Java documentation, they use that same way of doing things. Okay, so far so good. If I compile this, I still haven't satisfied this contract. It's going to keep telling me that, yeah, this is a problem, okay? So I need to then provide those methods. Okay, so I know I have to have a public Boolean push, which takes in some element. Okay, and I'm just going to return false with that one. And let me just make my life a bit easier and get rid of pop for now. Compile this. Okay. So I've removed this from the interface just to quickly show. Okay, as soon as I include this method, now this is considered part. This has the behavior of a stack. We have a valid method. Now it does nothing, but we have at least provided an implementation. Okay, so there's no real magic there. All it's saying is just provide me something called push that returns a Boolean that takes these parameters. Okay, and you can just write return false. It does nothing, but yeah. Okay, anyway, let's think about how a push operation works. Okay, we go back to our theory. so given an array, if we push a value onto it, we first increment top and then insert the value at that position top is pointing to. Okay, so we basically do that. We say top plus plus, okay, it's going to go from -1 to 0. And then we just say at that position, wherever top is pointing to in our internal stack, remember that's just the object array, that will become this element that we're passing in. Okay. The only thing left to do then is say, well, return true. Okay. Yeah, just compile that. Okay, so now I have a stack that should actually allow elements to be pushed onto it. Okay, let's just quickly do pop. Public, and we wanted the type with element, and we don't take any parameters. Okay, so now what we want to do is, if I go back to the theory, we want to get this element first of all, then decrement the pointer, and then make sure we actually return that element. Okay, so what we want to do first of all is, well, we need to return something, okay, but we need to return something from the array that currently is at top. Okay, so what we can do is just have a temporary variable or local variable, call it top element, okay, and what we need to do is get the current value at the top. Okay, once we've done that, we can then decrement top and move it back down the array again. Okay, and we can return our top element. Okay, now, in theory, this works, but because Java and generics, Java arrays and generics don't play nice together, we have to, everything in the stack array is considered to be object, but we need it to be in type E. Now we can guarantee it's in type E because we only ever take in things of type E, okay? Now, so whenever someone creates our array stack, they're going to say array stack of type string in their own code. Okay, that was a really bad way to write string. So they're going to provide that type. We don't know it in advance, okay? So it's messy code, but we can use a cast operation. So whatever comes out of this, whatever is currently the top element in our stack, we're going to convert it to this type, which is what we need to return. Okay, this is probably, yeah, the most confusing part, this kind of bit of magical cast operation. But we can trust this because generics create these rules, only this type is allowed. Okay, so I should be able to hopefully, now it compiles, but we are going to now constantly get warnings that we're doing very unsafe things. Okay, so it's a little dodgy what we're doing here, but we can kind of trust that when we push something into an ArrayStack, it can only be of type E. So this cast operation is going to be safe enough. Okay. And Elias, we can't make, yeah, I don't think Java lets you create that, which is the kind of problem. Let me actually try that just for sake of argument. Yeah, okay. Incompatible types. So, look over here. Should have done that in multiple places. Yeah, you get this generic array creation. Okay, so this is basically, you're not allowed to do this, which seems a bit odd, but if we just accept that we have to say, well, everything in Java ultimately is an object, so it's kind of safe to say this, but this type will actually be unknown until actually compile time. Okay. Let me go back to my, I did take that away. So we should have two methods, push and pop, and we should be able to compile it. Okay, so now we actually have a stack that works. Well, in theory, at least. Okay, let's take a 10-minute break. So back here at 1/4 past, and we'll actually see our stack in operation.